All right, vocab day for Unit 7. Notice this is part 1 because Unit 7 has a lot of vocabulary. We're just going to cover the first 2 chapters. And then we'll cover the next 2 chapters when we get there. First term is the sampling distribution, a probability distribution of a statistics obtained from a large number of samples drawn from a specific population. So notice I have my population. I'm going to grab samples from that population. I'm going to take their mean, and I'm going to compare that or graph it in terms of my normal distribution, or my normal model. So that is sampling distribution, grabbing parts of a population and then throwing it onto your normal model. The sampling distribution model is we can't see all samples, right? We can't look at everything. We can't get surveys from everybody. So we're going to use a model to sample the variation in statistics. So we're taking real-world data, we're turning it into an imaginary model of statistics, and then we're going to use this to interpret the data in terms of the real world. Kind of makes sense? Taking the real world, taking parts of it, turning it into a model, and interpreting that model in terms of the real world. Sampling and variability, or sampling error. How much an estimate varies between samples. So we look at here my sample and variability. Notice I only took 10 samples. Lots of variability, right? Well, let me increase that to 100 samples. A little bit better. Let me increase that to 1,000 samples. Look at how this is looking more like a normal model, right? So notice your variability increases or decreases as your sample size increases. Does my variability increase or decrease? Decreases, right? I have less variability here as I have more sample size. And again, it kind of goes with the same sample and error. So notice I have my population mean, and I'm taking samples. Here's my sample mean, and my sample error is the distance between the two means. Kind of saying the same thing. My variability between just one sample. We also have central limit theorem, CLT. If you have a population with a mean U and standard deviation of sigma and take statistically large random samples from the population with replacement, then the distribution of the sample means will be approximately the normal distribution. So we see here, we want to take as large enough sample as possible. So what I have is, here's my data, my pen. I want to grab this, and then I want to take the mean of that sample, and it gets thrown here. Okay? Now, look at it again. I'm going to take a different part. I'm going to take this part. I'm going to take the mean of that, and it gets thrown here. And as I keep on taking more and more random samples and throw them, the mean, it should represent a normal model. Did I explain that well? So as I keep on grabbing samples from here, taking the mean of those, all of those means should form a normal model. Oops. That is our central theorem, or central limit theorem. Standard error, approximate standard deviation of a statistical sample population. So we have 2 different types of formula for standard error. One for the proportions and one for the means. And we'll get more into standard error later. Now, standard error is a type of standard deviation, where standard deviation is the measure of the variability of the data in relation to the mean. Right? I have my data, I have a mean, and my standard deviation we know is distance from that. 1 standard deviation, 2 standard deviation, etc. Standard error is a type of deviation. It's from my distribution of the means. So I'm looking at all of my means and seeing what does that become. Notice with standard deviation, when we talk about categorical data, our standard deviation is that formula, which coincides with the standard error of proportions. When I'm looking at the standard deviation of quantitative data, I have this standard deviation formula, and it coincides with the for means of my standard error. So they kind of go hand in hand. Confidence interval is a range of values we are fairly sure that our true value lies in. So that is the glass half full definition. Glass half empty is how much uncertainty there is with any particular statistics. So I have my distribution. I have my mean. And then I have my upper limit and lower limit. Notice, but on the upper limit, I have outliers, right? Below my lower limit, I have what's called outliers. In between here is my confidence interval. This is how much confident I can say that 9% of my population will fall in. So I'm confident you will fall in somewhere in here. I'm confident you will, and you will, and you will. Right? Because it's rare, only 5% will be in here. That is our confidence interval. Margin of error. How many percent points your results will differ from the real population value. So notice I have an estimate. I have my confidence of interval right here. And my margin of error is between these two. This is my margin of error. So notice here, as my sample size increases, what happens to my margin of error? As my sample size increases, my margin of error does what? Decreases. Yeah. So it's all about taking as large number of samples as possible. And here's our formula for margin of error. I'm taking my C-score, multiplying it by my standard deviation, divided by the square root of my number of samples. Again, you're not expected to memorize any of these formulas. They're on the formula sheet. And critical value. Determining likely or unlikely by determining whether or not the observed test statistics is more extreme than would be expected if the null hypothesis were true. So it's comparing the observed test statistics to some cutoff value. So again, I have my distribution. I'm calling it, here's my cutoff value, and my critical values are these points right here. If I have anything outside, I can reject the null. Anything inside, I cannot reject the null hypothesis. And we'll talk more about that when we get into that chapter. But that is critical value. Deciding what is your range. More or less, you can think of it as your confidence interval. And I think that's it with critical value.